take a look at an example of integration by substitution. We begin with a quick review of differentials from Calculus 1. Differentials are expressions of the form f of x times dx, or d of g of x, differential of some function g of x, where x is the variable, and of course instead of the letter x we can use some other letter, y, z, or something else. And the key definition that we use to operate with these expressions is that the differential of a function g of x equals the derivative of that function g prime of x times dx. Here are some examples of differentials. Differential of x squared equals to 2x times dx because the derivative of x squared equals to 2x. Likewise, differential of x squared plus 1 equals 2x dx again, because the derivative of x squared plus 1 is also equal to 2x. And finally, differential of 1 over x equals negative dx over x squared, because the derivative of 1 over x equals negative 1 over x squared. Okay, now let's look at this example of integration by substitution. Suppose we need to integrate x times square root of x squared plus 1 times dx. The integration here is based on the following observation. First, let's rearrange the two terms in the function that we're integrating. I'm going to switch the order of x and the square root. And now, if you look at x times dx, and you compare it to the differential of x squared plus 1, which is 2x times dx, we see that x dx is equal to 1/2 of that differential, right? So here I can write that x dx equals to 1/2 differential of x squared plus 1. And now we can rewrite the entire integral as follows. Integral of the square root of x squared plus 1 times 1/2 differential of x squared plus 1. And what we see now is that everything here is expressed in terms of x squared plus 1. We have the square root of x squared plus 1, and also the differential is taken of the same expression, x squared plus 1. And so the idea now is that we can replace x squared plus 1 with a new, denote x squared plus 1 with a new letter. Let's say we use u. Okay. So I'm going to write here, this is how we typically write a substitution, and in between these vertical lines, u equals x squared plus 1. This explains that we are replacing x squared plus 1 with u, our new variable. Well, then we can rewrite the previous line in terms of u. We now have integral of square root of u times 1/2 du. And of course, the integral now has simplified dramatically. We now have a much simpler function to integrate. 1/2 is a constant which we can pull outside of the integral. And we can now complete this integration using the power rule, because square root of u is just u to the power of 1/2. And if we take that into account, we're integrating a power function. And so using the power rule, this antiderivative of u to the power 1/2 is going to be u to the power 1/2 plus 1 divided by 1/2 plus 1, and of course plus the constant of integration. We get 1/2 times u to the power 3/2 divided by 3/2 plus c, and this gives us our antiderivative as 1/3 times u to the power 3/2 plus c. Of course, we need to go back to the original variable x because our problem, our initial integral, was stated in terms of x. We didn't have any u here, and our answer should be in terms of x. U is an intermediate variable that we introduced to help us solve the problem, help us integrate. But all we need to do here is just replace u with x squared plus 1. And so we get 1/3 times x squared plus 1 to the power 3/2 plus c. And we can leave our answer like this, or we can also rewrite the power x squared plus 1 to the power 3/2 using a radical if we want. So 1/3 times square root of x squared plus 1 all raised to the power 3 plus c. Okay, now let's do a similar example. Integrate integral of x divided by square root of x squared plus 1 dx. And here, please pause the recording and see if you can do this integration. The idea here is going to be almost identical, almost the same that we just used. And then once you've tried this integration on your own, continue the recording and see if you did it correctly. Okay, so our process here is almost the same as in the previous example. We note that x times dx, which we have in the numerator, is 1/2 of the differential of x squared plus 1, and the rest of the integral is expressed in terms of x squared plus 1. So we can rewrite the integral as integral of 1/2 differential of x squared plus 1 divided by square root of x squared plus 1. And now changing x squared plus 1 to a new variable u is going to give us a much simpler integral. 1/2. 1/2 is a constant which we can pull outside of the integral, du over square root of u. Changing the square root to the 1/2 power of u to the power 1/2, and noting that this power is in the denominator, we can rewrite this integral as 1/2 integral of u to the power negative 1/2. And using the power rule, we can find the antiderivative as u to the power negative 1/2 plus 1 over negative 1/2 plus 1 plus the constant of integration. And this, of course, works out to be u to the power 1/2 plus c, which is the square root of u plus c. And now we go back to the original variable of integration by simply replacing u with x squared plus 1. Okay. And so that would be our final answer here. Okay, well, these are the basic ideas, and the takeaway what I'd like you to take away from these examples is that when we integrate by substitution, essentially what we're doing is we're working with differentials, which are part of the integral.